so I worked through these two extra questions, which are on the extra sheet. In the future, it will be included in the packet, but this year I accidentally didn't have it included in the packet, so it'll be on that extra sheet that I gave you. So anyway, in this particular problem, first things first, start out by changing it from subtraction to adding a negative. So move that minus sign up on the first numerator or a second numerator, but change it to addition. The next thing you do is factor the denominator. You can see we pulled an x out of the first denominator. We pulled a 4 out of the second denominator. Okay, and we got x minus 4 inside the parentheses both times. And then we asked ourselves, what is the first fraction missing, or first denominator missing that the second one has? Clearly it's a 4, so you can see I multiplied top and bottom by 4. And what is the second denominator missing that the first one has? And clearly that's an x. I'll clear those off so you can see what I'm talking about. Okay. So when we did that, the denominator isn't changing. Notice that I just wrote 4x times x minus 4 on the denominator. I do not expect you to FOIL that together at all. In the numerator, you would have 4 times 4, which is 16, and then a minus x squared. There are some of you that would say, oh, is that the same thing as 16 plus negative x squared? Sorry, I chose to start green with the black background. I apologize. But it is the same, and it's not going to count off if you decide to do that. Okay? Now, that's the full credit answer right there. But if you decide you want to go farther with this one, there is extra credit as an opportunity. The top, you'd have to factor out a negative 1. I know that's kind of a weird thought for some of you, but you would factor out that negative 1, giving yourself x squared minus 16. Then, which you can see that flips things around. That's a difference of perfect squares. So now this can be broken up into these two things, the x minus 4 and the x plus 4. And then you can see that one of the x minus 4s will be eliminated by reducing. There are like 3 different ways that I have written the final answer here. And so I would accept any of those if you're willing to show the work. But that's the extra credit for that particular question. Make sure you get that all copied down. If you want to stop with the full credit, that's fine. Okay, next, question 4. Sometimes I am, sometimes I'm not. Okay, so on this next one, we did the same thing, right? Move that minus sign up and change it to addition, because you guys are much better at adding than you are subtracting. So we factored the first denominator, that's x plus 3 and x minus 2. We factored the second one, that's x minus 2, x minus 3. Remember, they multiply together to give you the last, and they add to the middle. Okay? And then we asked, what's the first one missing that the second one has? And that was clearly an x minus 3. And the second one was missing an x plus 3. So I did that to the top and the bottom. Then we distributed the 3x to the x minus 3. When we do that, we get 3x squared minus 9x, which I put that up here. And then I distributed the negative 6x to those, and I get negative 6x squared minus 18x. Then those are like terms, we can add some of them together, right? For instance, the 3x squared and the minus 6x squared, those are like terms, and they can be added together to give me negative 3x squared. And then the negative 9x and the negative 18x, they add up to negative 27x. So, we end up, and that's the one that even if you do pull out a negative 3x and give yourself x plus 9, nothing in the denominator cancels, right? So this, even if I did this, I would not get extra credit because there's nothing that can reduce. So this answer was as good as it was going to get. There's your full credit answer for that question. Those are the only 2 problems on that extra page that I wanted you to practice. Um, yes, I know I went really fast through those, so you ask me questions in class if that didn't make sense.